Good morning, GM. Thank you, everybody here, for choosing to spend your time at our third inaugural NoirCon.
Hey, hello everyone. Yeah, so we are good to go and start to build our first ZK Noir mobile app. Okay, so if you're ready, we'll get started. So notice that this will be a workshop and talk like mixed style. So things like, I think, not sure, who here have developed on mobile before? Ah, that's awesome. Yeah, so there's some prerequisites that you have to install before that. So we're trying to give people some time to install it. So in the meanwhile, while people are downloading the prerequisites, we'll try to walk through what is Mopro in high level, and also some new features we have, some cool projects we had before, and then we'll jump to the workshop itself. So my name is Moven. I'm from PSE, Ethereum Foundation. So Mopro, so this is today's goal about the workshop. Yep, so if you haven't installed the dependency yet, so you can, these are the things you want to install. And I think the first column is kind of missing. So if you are using Android, you need to use, you can download Android Studio, and you can directly go to their official website to download it. And if you are using iOS, you can download Xcode, which is live on App Store, so you can directly get them. Let me see. Yeah, it's a full version. Okay, not sure why it's disappeared. Yeah, so we recently done a lot of things for cross-platform mobile development. So in order to get the first-hand experience, we recommend you guys to try Flutter or React Native for this workshop. So it does require some prerequisites. So if you haven't downloaded yet, feel free to go to Flutter's documentations or React Native one, to get you prepared. And last but not least, make sure you install Mopro CLI. It will help you to start your smooth process on building mobile ZK app. Okay, so if you have further things or you want to follow the documentations, you can also go to Mopro's website for that. Okay, so why people are install the prerequisites, I want to introduce what is Mopro in high level. So it's shorthanded for mobile proving. And what we want to do is that since there are some scenarios, especially in client-side proving, we want to keep 100% of our private data in the device we can control. Yeah, so that's why having the ability to have your mobile be able to do proving is very important to us. So we noticed this gap exists in the theory and realistic side. So we try to build Mopro to both enhance the developer experience and also the user experience. So that's Mopro, what we aim for. So our target is to help developers or projects to build privacy-preserving mobile app. Yeah. So actually, it's quite very easy to use it. So only 3 key comments you guys have to use in this workshop today. So first of all, you're going to need Mopro init. It's just init a Mopro project, which is essentially a ROS project. So inside of it, it have a library where you can define what kind of functions or business logic you want to expose to your mobile interface. Then we'll use FFI, foreign function interface, to port this ROS binary to mobile so that your mobile native platforms or languages like Kotlin or Swift can understand and directly access to these ROS functions. Yeah. So we use Mopro init to create this ROS library. And once you define the functions you want to expose to, you can go for the second one, which is Mopro build. So what Mopro build do is we will generate the bindings for your exposed ROS functions. And moreover, we have many functions about it. So if you are using native solutions, we have Kotlin and we have Swift. But more important, we recently integrate FFIs for cross-platforms like Flutter. We use Flutter Rust Bridge to like eliminate a lot of glue codes that requires, but also like have React Native FFIs inside of it. So I believe it will be a really nice developer experience. So we'll try that later. Yeah, so now you have the Rust library, you have the bindings that you generated for it, and the final step is Mopro create, which will help you scaffold a template app so that you can start building your mobile applications in no time. Yeah, so like also we have like native one and cross-platform one you can choose to. So very simple, just these 3 steps will help you get started building your ZK applications on mobile. Now I'm going to walk you through some examples projects over here. So first of all, I think since you're in Aztec crowds here, people are amazing, and I think most of you guys have heard of Stealth Mode. Yeah, and we actually built a mobile version for it. So it uses the same things underneath. It's like zkJWT that is written in Noir. And then we can prove this JWT using Google Auth, so to provide a really like smooth UX. And also you can prove that your organizations without revealing the post. And also you can verify, like user can verify each message is actually comes from the specific email address that these users posted from. Yeah. And also, like we have an interesting feature, which is the internal chat within organizations, so that some chat, if you're from these email domain, then you can have the access to see this internal chat. And also, one more thing that we want to highlight is about the UX on mobile. So if you can, if you have ever used Stealth Mode before, you'll notice that what you post is like pure text, right? But in mobile, we can add additional parsing about it. So we can actually parse the Modcon syntax so that you can have like format message like this, and also some tables, and also you can include images or like links inside the Stealth Nodes. So it's like directly extend the feasibility and functionalities of Stealth Node. Yeah. So if you're interested in it, it's also open source. You can download it and play, and also it's on test flight, so you can like download it on your iPhones and get the experience out of it. Okay. Next is that I think in the mid of this year, some people built this proof of geolocations where you can prove that you are within a certain distance that the circuits want to verify. Yeah. So circuit itself is quite simple. It first starts as a circuit, but I think there's a lot of people like translate it into Noir. So this is a really fun topic, in my opinion. And one big challenge for these applications will be like, how can you combine your mobile's GPS data directly port them into the circuits so that you can like make sure that users not cheat about it. But imagine that if we enable this, like there's like additional check for the maybe host of the event to verify whether if these people is like near around the venue while they're checking, or there's like many other applications will derive from this. Okay, and the next one will be the Solidity verifier in order to unlock the on-chain verification. So in Mopro, we support like Circom and Noir for this. Yeah. So not sure whether if everyone plays around with Noir's on-chain verification before. Anyone has? Not yet. Okay. Okay, that's great. So we also provide this template so that people can not only generate the proof offline, but also you can use this proof to send it to the smart contract and verify it on chain. Yeah. So with this template, I think later I'm going to show you a live demo about this. And also, if you're interested about it, you can follow this repo and try the Noir version. It will be very fun. But one heads up is that we only update because Noir and Barretenberg backend is update really, really quick. So we log into a specific version for this. Yep. So make sure you go to the repo and give it a check. Okay, and that's pretty much about Noir part, but also there are something we feel exciting and we want to share with you, that running ZKVM on mobile is actually possible. So this example is RISC-0. We put them integrated with Mopro and build a template app for it. So you can see the left-hand one is a very raw one that we directly derive from RISC-0's template. And the middle one is that we try to implement ECDSA verifications within RISC-0. Yeah. So this is quite cool experience, and the result turns out it actually works, but it has long execution time. I think our benchmark is close to 90 seconds for the ECDSA proof, but I think there's a lot of ways to improve that. And on mobile, we have some tweak that we can do for this kind of scenarios. For example, you can put these long generations of proof into background service, so you can even generate a proof while you close the app, and you just put it in your pocket, and once it's done the proof, it will notify you. So things like that is possible on mobile, and I think it will be the first step of running ZKVM on mobile, and I think this direction will generally greatly improve developer experience on mobile when they are trying to build a ZK app. Yeah, so we'll see. We're very excited on how this direction will evolve. And there's a cool one. It's called MobiScale. So I know that Theo is next door introducing face match. That's quite interesting. And we also received a hackathon project from East Global this year, doing this similar thing. They want to match people's face with their identity. Yeah. So he do it inside the TE to run the face match algorithm, and they use the Noir to verify the attestation generated from TE. So this is quite interested about it. And if you are curious about how does it work, you can also go to ETH Global page to check it out. Also some cool stuff some ZKNox team has built this project called Zkeeper, where they have several features. And I think each of them is very interesting. So first is that they have turned the wristbands of your ETH Global wristband into a signer, and then implement a post-quantum access control with EIP 7702 to do so. And last but not least, they have a raw version of Noir integration, which is super cool. And now we are focused on mobile, right? So the most important thing in mobile, I think, is the user experience. So ZeroSurf is from the last hackathon in New Delhi, and what it builds is enable a browser to do age verification using NoirCon, which is a verification protocol for India's Aadhaar identity. And it used deep link to achieve really smooth interaction. So I'm going to show you here. So hope the network is going to work. Awesome. Yeah. So you can see that when you go to some website and it requires you to prove that you are age of more than 18, and this demo used NoirCon to generate a proof to show that okay, you have you hold valid identity that can prove that you over 18, and once you do that, it will redirect you back to the browser itself, and then you can see that the content is now unlocked. Okay, so we got projects that we built from ourselves. We also have projects that from ETH Global Hackathon, and as we keep building this ecosystem, we found there are some projects from the community. So this one is called Solidarity. It's live on iOS now. Let me adjust it. Okay. So it aimed to build a business card with privacy-preserving features inside of it. And it used like Semaphore Swift for group management. And I think the most interesting thing is that it integrates AirDrop. So imagine that one day you met other people, maybe in NoirCon 3 venue, you grab out your iPhone, the other people grab out his, and you're just like, hey, can you AirDrop me your business card? And boom, it just appears and stored in your Apple Wallet. And like with Semaphore built within it, you can send a message like to the similar group of people that inside the group, you can send anonymous message to them. Yeah, so this is very interesting. I believe there are still like fastly iterate through improvements. But I just want to show you guys that these mobile things with ZK integrated is like on the way. Okay. Okay, so there are a few things we will do after Devconnect. The first is that notice, if you can remember, we just said that you have to run Mopro init to create a ROS library so that you can add the functions you want to expose to them, right? So actually this part, we think some people who are more familiar with mobile development, they might not familiar with this. So what we're planning to do is that we put the ROS build part directly within the build script of your mobile app so that you don't have to care about anything about ROS. You can focus on developing your mobile ZK app. And second is that now we have FFI for ROS. And it's also like very interesting thing to extend the functionalities to other languages. For example, we can go for use Go or C#. And with C# unlock, this actually can build a lot of like Unity games or other like synergy for it. So it's very interesting. And also Python, like potentially for some ML scenario. And we also like have these new things called Mopro Pack, which is like we want to help people to pack pack their libraries they built, and they can release it as a native package so that any other people, they can directly use this as SDK in mobile platforms. Yeah. So it's essentially enhance the developer experience. And last but not least, like I said, ZKVM can greatly improve the developer experience on develop a mobile ZK app. So this is also a direction we are looking to. So if you're like interested about it, I would suggest that later in the workshop, you can try to install these RIG0 templates inside your phone so that you can get the first-hand experience about it. Yep. And also, we think in client-side proving, like performance is one of the things that we care a lot in order to like make all of the scenario for users very smooth, so they don't have to wait 10 seconds like for proof generation. And one direction is that the GPU exploration. So if any one of you inside of here like would be interested in this project, or you have built similar projects on GPU that runs on your mobile before, like make sure to like talk to us after this workshop. Yeah, we would love to like get your opinion and to see how we can work this out and push the boundary together. Okay, I think that's pretty much about like the high-level view about Mopro and what we're going to do like after hands. So without further ado, I think we're good to go and start to build the first, your Noir app on mobile. So raise your hand if you haven't installed Xcode or Android Studio. Okay, okay, still installing? Ah, the network issue. Okay, no worries. So later in the work, if you want to build Android app, I think you can directly download the dependencies that we need. But I think Android Studio will provide the best, like the most easiest installations for you. Yeah. And since we'll start for the workshop now, so later on, if you have any questions, you can go for Vivi over there. Say hi. Hi. So Vivi and I will help you guys through the entire process of this workshop. Yeah. So I will give you guys a really high-level view on what we're going to do in this workshop. And if you haven't followed it yet, or you cannot get the dependencies installed right now, it's totally fine. You can directly go to our documentations, and you can try it. And maybe when you are in a place, have better network connection, or you have some spare time for it. Yes. So what we're going to do is that first, get the CLI ready, and then we were going to build a template app following these three commands that we introduced before. And so since this is we are trying to build a Noir app, right? So make sure you choose Noir when you init the Mopro project. And next, you can choose either Flutter or React Native and when you're building FFI, and also create a template app for it. And now I think all the things will be good to go if you only run these three commands. And now you can plug your phone into your laptop, or just start an emulator so you can mimic a phone inside your laptop to run this app. Yep. And this will be the first step. Okay. So after you complete this step, there's a second part, which is more challenging. We want to introduce you guys how to update the logics inside the template app, so you can put what you are written, any expose function that you want inside of Mopro project. Yeah. So you can either add a new Rust crate, or try our another Noir app template, and then you can run Mopro build again to generate the new bindings for it, and run Mopro update, so that we will help you update this FFI to the correct space of your app. Yeah. And if you don't know what Noir app templates is available, you can try this on chain verification one. So yeah, so it used Noir beta 0.8 version. I think it's 3 months ago, and also the Barretenberg one. You need exact the same version to do so, because the Acer which have been compiled could be a little bit different. And but this is a very interesting version, so it already has some mobile-friendly features of it. So when you are in Noir, you will notice that if you choose Noir template, you can find out that there are some options you can tweak. For example, you can choose whether if this proof use catcheck or Poseidon as your Oracle hash. Yeah, so if you choose Poseidon, it runs faster in your off-chain verification. But in order to do on-chain verification, you have to use catcheck for Oracle hash. And also, since mobile is very memory constrained, average phone nowadays have only 4 GB of memory. So it is very important to have a mild memory consumption, and Noir enables low memory mode. So if you find your program is quite big, you can also tweak this low memory mode on, so that it can run smoothly on your mobile. Though it will give you 2x slower, but it won't make the app crash. Yeah. So yeah, so let's get started on the workshop. Okay, let me move to here. Okay, so right now, it's a little bit small, right? Right now, first of all, we have to verify whether you have the CLI download. If you haven't, you can just run cargo install Mopro CLI, and you will get it to our latest version of 0.3.2. Okay, so once you have it, we can run Mopro init to create a Mopro repo for this. So since this scenario is NoirCon 3, so let's build a NoirCon 3 app. Okay, and just choose Noir as the thing we want to use. And one caveat here is that we do build extra support for proving system like Circum, Halo 2, or Noir, but actually you can choose none of the above. So what will you get if you choose none of the above? You will get a really nice FFI wrapper so that you can port any functions like you want to compute MPC protocols, you want to compute FHE, you just import these Rust crates inside the Rust library of Mopro projects. Then you can also generate the bindings for them and make it run on mobile. So this is some caveat. Okay, so now you'll see that we have this Mopro projects generated. Let me walk you through what's inside. So like essentially only these things like this library.rs like matters the most. So you can see this default expose function right here. So you can just essentially import any like crates you want to use inside of this lib.rs, and then like invoke them within a public function. And on top of it, you only have to add this macro to ensure we have XSI like expose it to UniFFI so that when we are generate the bindings, it knows which functions is going to like expose to the mobile interface. Yeah. So just like create whatever functions you want and add this macro on top of it. Yeah. And it also supports some custom structure. You can also export this structure or data types with this macro. Yeah. So this is what we do over here. And there is also the Noir, like high-level APIs we've already wrapped. So you can like generate the bindings in a more user-friendly way. So if you can see that there's some like this on-chain booleans that you can like choose whether to go for cat check to enable on-chain verification, or like false to enable Poseidon as Oracle hash for faster off-chain verification. Yeah, and also this low memory mode that we previously introduced. Yeah, and okay, so that's pretty much about the interface you have to know as you play around with Mopro. Okay, so now we have it. That's back to the demo. So let's say you have already like add the functions you want to expose to mobile. So now we are ready to generate the bindings that port this Rust functions binary and generate FFI for them, and so that the mobile platforms like Kotlin or Swift can understand and invoke these Rust binaries. Okay. So that's from Mopro build. Oh, sorry. We have to go into the project first. So that's from Mopro build. Okay. And we choose release modes for the best performance, and you choose Flutter FFI. Okay, so just wait for it to compile a while. So while this is processing, I want to know if there's anyone like following this workshop. Awesome. So have you faced any problem yet, or okay? Too many requests. Thank you guys. You are very warm crowd. So, okay, I think maybe like give it a second, or you can check the documentations when we back to a place with better internet. Sorry? So are you asking what's the difference during Mopro build? What's the difference of iOS, Kotlin, Flutter, and React Native? Okay, that's a great question. So each different platforms, I think, have its own like best suited FFI. So beforehand, like we only have Android and iOS FFI. So we have to we use UniFFI to generate the bindings for iOS and Android. And later on, if we are using some cross-platform framework like Flutter, we plug these two bindings into them. And we have to write some glue code to make sure that the Flutter understands the native bindings of iOS and Android. So that's a previous one. In the new Mopro, we integrate FFI for each different platforms. So we have, for Android and iOS, we use UniFFI. But if you can see right over there, let me try to score a little bit up. Okay, it's not oh, you can see, yeah, it's right over here. So for Flutter and React Native, we use its own FFI. So you can see that in this case, it identified that, oh, we are actually choose Flutter. So it switched from UniFFI to Flutter ROS Bridge to provide a better binding interface in this case. Yeah. So I would suggest that though iOS and Android bindings is a good option as well if you are building mobile app. But if you are using cross-platform solutions like Flutter or React Native, you can try to use its native FFI instead of using UniFFI. Okay. So you can see that it's compiling the bindings for it. It's right over here. Yep. Okay. So it is already built. And I want to show you guys what the binding looks like. So you can find that we have this Mopro Flutter bindings over here. And actually, it is quite lightweighted. So before, if we use UniFFI, it would generate the bindings generate the binaries for these Rust functions, which is quite big sometimes. So for example, if you are building an iOS bindings, sometimes it will be few hundred megabytes or even gigabyte level. But in Flutter ROS Bridge, we use 4 right now. It won't build the exact binaries when we are generate this binding. So it is lightweighted. You can commit them to your GitHub for version control very easily, and the binary will only build when you are running Flutter run, and when you're building the app, this ROS binary will be built at that time. Okay, so this is the bindings. And it helps us, it also includes a lot of glucose inside of it, so we don't have to write them manually. Okay. So is there anyone generated the binding? Not yet, okay. So that's all right. You can try this tutorial when you're in home. Okay. So now we have Mopro projects ready. We already generated bindings. The final step is create a template app for it. So that's run Mopro create. So you can see that you can choose this many different templates. So let's choose the Flutter one. Okay. Okay. What's the issue here? Is it a network error? Okay, so previous error is network issue. Now we have it here. Okay. So you can see that we have this template Flutter app inside of it, and the main logic will be live in this library main.dart here. So you can see that it imports the binaries that generated by Flutter ROS Bridge FRB, and then also this exposed and ported functions from Rust right over here. And you can invoke them natively within Dart. For example, let me go to generate Noir proof. Okay, so you can see that it is actually wrap into the interface that Dart can understand, so that you can build this Flutter app very easily. Okay, so let's try to run this template. And before this, let me start the emulator. Let's run the iOS one. Okay. 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 Perfect. Okay. Now we have the emulator right here, so we can run. We can go for Flutter run. It will like automatically detect which emulators you're on. Oh, sorry, you have to go into Flutter directory. Okay, let's do Flutter run. So let's choose the emulator and wait for it to compile. So it might take a while, and that is also a benefit as a if you are using Mopro to develop the Noir app. So in the meanwhile, you can get yourself a tea or some coffee, yeah, or some snack. My personal favorite is like I will have a chess match in between this building time. Hi. Oh, yes. Yes. Uh, I think the circuit of geolocation is easy to implement. You have to check the like geo distance between 2 points. You can get the latitude data and longitude data from GPS, right? And you put them into constraint. I think the hardest part is how do you connect, make sure that the GPS data that received from the phone directly ported into the circuit without some contamination. Yeah, I think that's the hardest part, and I think some people has already explored that, but they don't have a great solution right now. Yeah, so proof is easy. You can just, if you're like doing POC, you can just use some default data for that. But if you want it into production, you need extra works on make sure the GPS data is not like colluded. Yeah. Okay. Now you can see it's already built, and you will install the app inside your emulator. And one thing that I love Flutter the most is that it has like hot reload and hot stop feature. So it makes the development also very smooth as well. So it's actually not harder than web browser, like building a browser app. So once you have all the dependencies configured, I think it's like quite easy. And also you can build something with quite a good user experience with it. Yeah. So you can see that since it's a template app, we have like defaultly implement the interface for Circum Hello 2 and Noir. And in this case, we just go to Noir 1. And maybe let's say let's just change the public inputs to like November 20 and generate a proof for it. And then we can run verification about it. So you can see it's pretty raw. It's just a template application. So in the real production, you have to modify the interface inside of this your Flutter app, specifically in this main.dart, to like ensure that your UI and your business logic of the app looks great. So this is So this will be the first part of the workshop. And if you want to change any logic of the app, you can directly go to the Mopro projects library, which is where we expose the functions, and just add anything you want and generate the bindings again and run Mopro update to do so. So since we have some time constraint today, let me just run a real demo in my Pixel phone right here so that you can understand a more a template app that runs Noir and with more functionalities. So let me just run this to port my to mirror my phone to laptop so that you guys can see it. Let's see, where is it? Yep, it's right here. Oh, okay. Oh no. Oh no, people are seeing me. No, sorry for it. Okay. Here we go. And okay, so this is like my phone, like in real life here. So this is a Noir app that we built before. It is the Wallet Connect one. So if you want to play around with this one, you just go to the GitHub repo and clone it, and just run Flutter run, and you can also start this as well. Okay, so let me disconnect the wallet first. I want to demonstrate something. So it is also like very similar like multiplier circuits, and you can just like generate a proof for it. And you can see the time. I'm not sure whether you can see the timing really clear. It's at the below. So it's around like 300 milliseconds. And if it's a cat check proof, it's also under 1 second. So it shouldn't be long, thanks to we have the nice proving backend in Noir. And now you can verify it as well. It's valid. And we want to demonstrate the ability to connect to on-chain worlds. So we have this Wallet Connect with Reons using their app kit. So let's connect MetaMask. Okay, we connect it. Sorry. Okay, and we show the connect. So this thing is actually powered by Deep Link, so it can transit in between apps very smoothly. Okay. Okay, so you can see that now it's already connect. We can run this verify on-chain feature over here. Yep, so you can see that it works. Like, and the speed is according to like the connection of you or the RPC node that you choose. So I'm not sure if you can see that. It's around 700 milliseconds to verify the proof. Okay, so this proof is like 16 KB. So it's like mild size of the proof. Yeah. So this is the more like advanced one you can play around with. And for full feature of Noir app, you can also download Stealth Node mobile version and build it on your laptop. Yeah, and to play around with it. Okay, so this is pretty much about the demos for today. And so right now we are actually trying very hard to push, increase the people building mobile app in Web3 space. So I think people here are very care about privacy. You guys know how important it is, right? So if you want some privacy that people can use in their daily life, not only with their laptop, but also their phones, we need to increase inclusions and make building mobile apps with ZK more easily. So that is still gonna be the goal of Mopro is trying to do. Yeah, and also we are looking forward to push privacy in mobile community. So we are going to walk into Web2 world and try to have them know the importance of privacy and include more mobile native builders. Yeah. So thank you for joining today's workshop. I hope you have great experience. And if you are interested about it, you can also follow our documentation. We have very nice get started and some write-up and also some blog you can look into. And we are live on the Telegram group. So if you want to find us, you can go to the group and make sure you follow us on X for any latest update. So thank you so much.